Hello everyone. This video will show how to simplify complex rational expressions. Now let's go over this example right here. I'm just going to go ahead and rewrite this expression that we have down here. The trick in simplifying complex rational expression is that we need to work on one of the parts. It's either we're going to do the numerator first or we're going to do the denominator first. So we're not mixing them all up together. So in this case right here, I'm going to go ahead and cover the denominator and work on the numerator. If you notice, these two terms that we have here do not have the same denominator. That means we cannot add them together. So that we can make their denominators the same, we're going to multiply 1 to the first term here in a form of x over x, which is the denominator of the second. So if we are going to rewrite this expression would come out x squared over x. So you have x times x is x squared over x, and then plus 1 over x. So if you notice, they already have the same denominator, so that we can already add them together. So we collect their common denominator, which is x, and we're going to add the numerator, so that is x squared plus 1. So this is the simplified version of the numerator. Now let's go over the denominator. In the denominator, we don't have to do a lot of work here because it's just equal to x. So then from here, we can go ahead and simplify this. To do this, since this is division, we are going to copy the numerator first. When we divide complex rational expression, we remember that we're supposed to flip the denominator and we multiply them across. In this case here, I copied the numerator. This x here has an invisible denominator of 1. So that we are going to get the reciprocal for this, or we're going to flip it and we're going to multiply it to the numerator. So that would be times, flip this, so that is 1 over x. So that we can go ahead and get the answer for this. And we just have to multiply them across. So that is x squared plus 1 multiplied by 1 is still the same thing. That is x squared plus 1. And then x times x is x squared. So this is the simplified form of this given rational expression that we have up there. Now let's have another example. Okay, so let's go over this example here. I'm just going to go ahead and rewrite this given expression down here. If you notice, the numerator is 1, so we don't have a problem with it. So it's already simplified. Now we are going to simplify the denominator. Looking at the denominator here, this one is an invisible denominator of 1. This one is an x. So I have to multiply 1 to the first term in a form of x over x, so that their denominators are the same. So the expression would come out. If you notice, their denominators are the same already. So we can go ahead and combine their denominators. So this would come out 1 over, that's going to be a common denominator, which is x. So that is x squared plus y squared. Now to simplify this further, we remember that if it's a complex fraction, we copy the numerator first, which is 1, and then we flip the denominator and we multiply them across. So that would be x over x squared plus y, because that's y squared, because again, we need to flip it. So then this tells us that the final answer, or the simplified form for that, would be x, since this is multiplied by 1, so that is x over x squared plus y squared. So this is the simplified form for this expression up there. So let's go over this example right here. So we are tasked to simplify this given expression up here. So I'm just going to go ahead and rewrite it down here. So what I did here was I put an invisible 1 under 4, because that's actually a fraction. The 1 here becomes invisible. So that we're not overwhelmed with this given expression that we have right here, the trick is to cover the denominator and work first on the numerator. So I'm going to go ahead and cover the denominator up here. So we're going to go ahead and work on the numerator. If you look at this expressions that we have right here, they don't have the same denominator. So we have to make sure that their denominators are the same. So what I would do is I will multiply both the numerator and the denominator by x plus 1. And then this is x plus 1 right here to make their denominators even. So that if I do that, our expression would come out. So what I did here was I distributed the 4 to each of the terms inside the parentheses. So 4 times x is 4x, 4 times 1 is 4. So then you notice that they already have the same denominator so that we can go ahead and add them together. So that we can go ahead and distribute the negative here to each of the terms inside the parentheses. So then this would come out. We can go ahead and simplify this. We can combine like terms. So 3 and negative 4. So this would come out. So this is our numerator. So let's now uncover the denominator and work through it. So what we do here is that since they don't have the same denominator, this one has an invisible denominator of 1. So what I would do is I will multiply 12 by x plus 1 to make their denominators even. So that's x plus 1 over x plus 1. So our equation would come out. So what I did here was I distributed the 12 to each of the terms inside the parentheses. So 12 times x is 12x, 12 times 1 is 12. And then they now have a common denominator of x plus 1. So I'm going to go ahead and rewrite that down here. So we can go ahead and distribute this plus into the x or inside the parentheses and our numerator would come out. Now we're going to combine like terms. In this case here we have 12x and x. So this would come out. And this will be our denominator. So then we go ahead and simplify this further. To do this, we are going to copy the numerator, which is negative 1 minus 4x over x plus 1. And we are going to flip the denominator and we multiply across, which in this case, our x plus 1 is going to go as the numerator, and then the 13x plus 12 will go to the denominator. Now looking at this, we can go ahead and cross out x plus 1 and x plus 1. So this would come out. That would be the leftover on the numerator is negative 1 minus 4x over 13x plus 12. You can take this as the final answer, or we can go ahead and simplify this further so that we don't get a negative. So this can also be expressed as take the negative out, and then that would be 4x plus 1, and that is over 13x plus 12. So this could be the other answer to this. In this example, we're going to have a term that has a negative exponent. So let's go over this problem here. So I'm just going to go ahead and rewrite this given expression here such that we don't get a negative exponent. So this x to the power negative 1 is equivalent to 1 over x. And then that would be plus x over, then I'm just going to go ahead and rewrite this. So these two expressions that we have here are equivalent expressions. Notice again that we don't have a negative exponent for the second equivalent expressions here. So I'm just going to go ahead and rewrite this given expression down here. The trick in simplifying complex rational expression is that we're supposed to simplify one part after the others. In this case right here, we're going to simplify the numerator first and then do the denominator later so we don't get them all mixed up. So what I'm going to do is I will cover the denominator first and then work on the numerator. Now please notice that the denominator of these two terms here are not the same. So what I would do is I have to make them the same, and in order I can do that, I am going to multiply a 1 to the second term here in a form of x over x. So this numerator will come out. So if you notice, we already have the same denominator. So we can go ahead and add them together. So we're going to collect the common denominator, which is x. So that would be 1 plus x squared. So this is the simplified version of the numerator. Now let's simplify the denominator. Looking at the denominator here, they don't have the same denominator here. So we have to make them the same. So we will multiply the first term with a 1 in the form of 2 over 2, which is actually this value right here, so that their denominators will be the same. And then I will multiply the second term with a 1 in the form of 3x squared over 3x squared. So that if we do this, we can actually simplify this as... So what I did here was 2 times 2 is 4. 1 times 3x squared is 3x squared, and that's a minus. 3x squared times 2 is 6x squared, which is the same thing as this. So they already have the same denominator. So I can go ahead and write 6x squared as their common denominator, and then write 4 minus 3x squared. So this is the simplified version of the denominator. So what I would do now is to divide these two together. So if we're given a complex fraction, which means the numerator is a fraction and the denominator is a fraction, the trick here is to copy the numerator. So write it out. Now what we do next is we get the reciprocal of the denominator and we multiply them across. Or we are going to flip the denominator. So flip this, that would come out 6x squared over 4 minus 3x squared. So flip it and multiply across. Notice that we have common terms here. So there are 2 x's and there's 1 x here. So I will take one of the 2 x's and the x will go away on the denominator, leaving us with... So this is the simplified form of this given expression that we have up there. So what I did here was I just multiplied them across, and this is our answer. We can also distribute the 6x here so that the answer could also be this one. So if we distribute this 6x to each of the terms inside the parentheses, it would come out this. In this example, we are given negative exponents. So let's go over this problem here. In order we can simplify complex rational expressions, we need to get rid of negative exponents. So this is how we do it. So what we do here is we will make this exponent positive by writing 1 over x squared. So if you notice, the 2 now is positive, and then that is minus 5 over x. We do the same thing here, so that would be plus 1 over y squared. So these two expressions are equivalent, but the second expression that we have right here do not have negative exponents. So I'm going to go ahead and rewrite this expression down here. In order that we can simplify complex rational expression, we are supposed to simplify either the numerator first or the denominator first so that they don't get mixed up. So in this case right here, I'm going to cover the denominator and simplify the numerator. If you notice, the denominators of these two terms are not the same. However, I can multiply 1 to 5 in a form of x squared over x squared so that their denominators are the same. So that this would come out. If you notice, their denominators are already the same, which is x squared. So I can go ahead and collect their common denominators down here. So that is x squared, and that's 1 minus 5x squared. This is the simplified version of the numerator. Now let's simplify the denominator. If you notice, their denominators here are not the same. So this is y squared and this is invisible 1. So I'm going to multiply the second term by 1 in a form of y squared over y squared to make their denominators the same. So the denominator here will come out. Notice that their denominators are already the same, which is y squared. So I'm just going to write that down here. And the numerator of the two fractions here would be xy squared plus 1. So this is the simplified version of the denominator. Please notice that this is an example of a complex rational expression because the numerator is a fraction, the denominator is a fraction. To do this, we're going to copy the numerator first. Now, what we do is we are going to multiply the reciprocal of the denominator, meaning we are going to flip this and we multiply it to the first. So this would come out y squared over xy squared plus 1. So what I did was I flipped the denominator. Now, I would have to multiply these two terms together. So the answer would come out. Since there are no common terms for these two and these two, we can just go ahead and multiply them together. We can also distribute this monomial to each of the terms inside the parentheses so that the other version for the answer to this would be. So what I did here was I just distributed this monomial to each of the terms inside the parentheses. So that is how we simplify complex rational expressions with negative exponents.